lot of graphing over the last several lessons, and I thought this was a good time to remind you that you should be practicing with pencil and paper. If the only graphing you're doing in Pearson MyLab, you're going to have a great deal of difficulty if you end up writing a paper test or exam, or if I ask you to verify a question with me. So make sure you've got paper in front of you. Better yet, make sure you have these notes printed and in front of you. So we want to look at another transformation or another set of transformations in the next two lectures. These are our vertical stretches and compressions. And again, we're going to start with that basic quadratic function. You can see here that I've added two extra ordered pairs. We have our basic or our key points that you've memorized. But I think for the purposes of really seeing what happens with these stretches and compressions, it's good to use -2 and 2 as well. Remember what we said back, I guess at the beginning of week 2, I reminded you that f of x represents y. So we're saying that y equals x squared. So that means here in my next function, I have 2 times y. X is staying the same, and we're multiplying our y coordinates by 2. X is staying the same, multiply by 2. X is staying the same, multiply by 2. X is staying the same. X is staying the same, multiply by 2. Why don't you graph those ordered pairs? I hope when you look at the two graphs, when you compare our basic function and then f of x equals 2x squared, you can see that this graph has been stretched. It looks taller, it looks thinner. We say that this is a vertical stretch. It's a vertical stretch by a factor of 2. We have another equation here, f of x equals 1/2 x squared. So again, we know that x is staying the same, and we're multiplying our y coordinate by 1/2. Why don't you find those new ordered pairs and graph that function? In this graph, you can see that it is much shorter. It is compressed. It is wider and shorter. This is a vertical compression. Oh, I'm going to run out of room. There we go. And this time the factor is 1/2. So when we have our function with some factor multiplying the function from the outside, we're not multiplying inside on x, we're multiplying outside the function. When the factor is multiplied by the absolute value of a, so we're looking at the positive value of a, we will say that the graph is vertically stretched. If the absolute value of a is greater than 1. When the function is multiplied by the absolute value of a, but this time a is between 0 and 1, so we're looking at a fraction, we say that the graph is vertically compressed. And we saw that when we multiplied by 2, a number greater than 1, we stretched the graph. When we multiplied by 1/2, a number between 0 and 1, we had a graph that was compressed. And we know that x will stay the same, and we multiply y by that factor of a. Let's start putting some of this together in practice in the next lesson.